What were we talking about right at the end of class last time?
I think you had at one point blockchain.
Okay.
Info. I think we were looking at some documentation.
Okay, we were looking at the API already?
We were looking at. I think we were talking about voting still.
Okay, so let's try to start moving towards the technology side of this. So we're going to assume that some of these problems dealing with making sure people don't vote more than once, blah, 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 we're going to assume those problems are solvable but not necessarily relevant to what we're trying to solve. We're specifically solving the problem of accurately counting votes. Fair enough? In a public forum. So we're going to use the Bitcoin blockchain for doing that. So the next thing we need to figure out is, how do we read from the blockchain? So we have this global blockchain. It's just out there and it's copied a zillion times, blah, 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 blah. How do we gain access to it? Well, if you look at Bitcoin wallets, just do a search for Bitcoin wallets. There's going to be a whole bunch of different things, and here's this. This is kind of bitcoin.org. It's a tutorial thing for finding wallets. So here's all sorts of different sources for wallets. And so we have mobile wallets, we have desktop, we have hardware wallets. That's kind of a new thing where people are starting to sell. It's almost like a jump drive. That's your physical wallet, so it's a physical secure ID. And then web-based wallets. So, for instance, isn't Coinbase on? Yeah. So Coinbase has a wallet, blockchain.info. So I have a wallet with both of these. I also have a wallet with CEX, but CEX is more than just a wallet. Go ahead.
So what you're saying is, for the hardware wallet, we need to just make it small enough that it can replace your credit card.
Or live in you.
A bio wallet.
By the way, I used Apple Pay for the first time yesterday.
You didn't use it
At
at
McDonald's?
McDonald's?
I thought we were going to use it every time.
That was the plan. McDonald's. I only go through the drive-through McDonald's. They were supposed to have them outside. They don't yet.
But you used it yesterday.
I did use it yesterday. I missed an opportunity to use it at Walgreens last week while picking up product.
How did you miss an opportunity?
Laxative type product. But after I swiped my credit card, I recognized they have the sign that says accept Apple Pay. So Walgreens does accept it. But so I did it at the Apple store. So you before you press anything, you just hold your phone near the sensor, and then your phone just comes to life. And it pops up showing you the default payment option. And then if you're happy with that, then you just put your thumbprint on there, and it takes like, I don't know, maybe 3 seconds, 4 seconds, and then you're done. At least I assume I'm done, because I grabbed the product and I ran out.
Wait.
So I specifically went into the Apple store to buy something. I didn't need it. So I can use Apple Pay. So in any case, we have a bunch of different types of wallets. Now, each of these comes with various security issues surrounding it. So if you're going with a web wallet, so for instance, Coinbase, if I want to see my Coinbase wallet, you log into your Coinbase account and they manage your wallet for you. So they're making sure your private keys are backed up and all that stuff so that you don't lose access to your coins. Now, at that point, if you're on the web, you're trusting Coinbase, right? You're trusting Coinbase to not steal your crap, because they are giving you access to your wallet and they're keeping your public and private keys and everything like that for you. You know, they probably publish somewhere that they don't, directly have access to your wallet or something like that, because they don't store your password. But anyway you cut it, they could be lying to you. You are trusting somebody. Okay, so any sort of web wallet you're trusting. If you read any kind of pro-Bitcoin literature on the web or anything like that, you're going to get a pretty, you're probably going to get the die-hard Bitcoin people pushing back against web and mobile wallets. They're going to really like these desktop wallets and hardware wallets, because you have physical control. You are in charge of these. Okay, so think of this like your own car keys. Okay, so to use your car, you have to physically have that key. That key is with you, and if you lose the key, you lose access to your car. We, with cars, have a backup plan, right? We can get a locksmith, and they can get into the car, and then somebody can make another key for you, blah, blah, blah. We don't really have that with Bitcoin. So the Bitcoin world would be you lose your keys, you lose your car. Go ahead.
Why don't they like it like mobile?
Well, because you are still trusting a third party. If you're using one of these mobile apps, KNC Wallet, Hive, whatever, blockchain.info has a, actually I think this is just a mobile website. I don't think they have an app. Could be wrong, doesn't matter. But you are authenticating with this. So you are still trusting a third party, not just yourself. Desktop wallets, you literally download, depending on the wallet. Let's just look at the Windows ones. There'll be a bigger one. So Bitcoin Core, this would probably be like, let's call it the most popular wallet. Reason it's probably the most popular wallet, I don't necessarily have numbers to back that up, but my guess is it's probably the most popular wallet, is you already have a subset of the full population that use Bitcoin, right? Out of that population, only a subset of the Bitcoin using population is going to be more like me, where I'm fine using a web wallet, stuff like that. I figure, if you got to trust somebody. That's kind of my philosophy on things. You got to trust somebody, and if they end up screwing you over, there's probably bigger things going on than, I guess that type of stuff. Just like the economy. If you worry about trusting your accountant or something like that, well, it doesn't matter. If China takes over, all our money's gone. So there's probably bigger fish to fry than the money that you lose from somebody else, being unethical. But in any case, so let's just call it a pretty high percentage of Bitcoin users are going to fit into that category of die-hard Bitcoin people who will only use desktop wallets because the reason they like Bitcoin is because it's decentralized and super secure and blah, blah, blah. And they don't want anybody else to have access to their stuff. And they don't trust banks, all this other stuff like that. So they're going to be drawn towards something like this, a desktop-based wallet. Okay? Now, we can look at some of these different wallets, but I'm just going to kind of give you the 2,000-foot view. Some of these wallets are only going to download a portion of the blockchain. Okay, they're only going to download a portion of the blockchain. Bitcoin Core downloads the entire, something like 17 gigabyte blockchain right now. So they'll download the entire thing. So when you download Bitcoin Core and you say, okay, I want to create a wallet, there's a setup time. while it is downloading the entire 17 gigabyte blockchain to your local hard drive. Okay? Now, why is it doing that? Well, it's going to parse that blockchain. That's something we're going to start talking about today. It's going to parse that blockchain to keep tabs on where your current balance is, right? Now, the initial setup is what's going to take the time. So let's say you already had a wallet. So let's just kind of fast forward a little bit. Let's say you had a desktop wallet, you had all your private keys and stuff backed up, you've reformatted your computer, and now you want to get your wallet back. So you download Bitcoin Core, you do the whole syncing of the current blockchain, you restore your private keys so it knows that this is the wallet associated with you, and then it's going to go and it's going to parse that blockchain in its entirety. Until it can no longer find transactions from you or that are related to your wallet. That makes sense? Okay? Once it parses it that one time, now it's up to date. It only needs to parse from that point forward because old blockchain entries aren't going to change. That makes sense? But it is a public record. So one way we can get the blockchain is by downloading one of these desktop wallets and having the entire blockchain local on a hard drive. And that wallet would automatically keep it updated. So that'll just be like a giant text file, something like that. Another way we can get the blockchain is there are many sources out there on the internet that provide the blockchain for us. They've already downloaded the 17 gigabyte blockchain. And at any point in time, you can just request the blockchain from them and download the entire 17 gigabyte blockchain. Okay? Or there are sites out there, blockchain.info being one of them, where you can go to that site and you can send them queries and they'll give you responses back from their copy of the blockchain. So rather than them delivering you the blockchain, you are trusting their version of the blockchain and the results that they give you. Does that make sense? So, still talking in this voting world, if we want to make sure that we have valid votes, we're probably going to have those official, because it's going to be a public vote, right? There's no problem with us going out to blockchain as the people who are writing the software. Us going to blockchain and doing our vote tallies on there for an initial tally. We should also do tallies on the blockchain from multiple sources. Those voting tallies should be the same across all of them. If they're not, that means somebody's blockchain's wrong, right? So it would be in blockchain.info's best interest to not manipulate their chain. And actually, they can feed us bad data without manipulating the chain. So let's think about that for a second here. If we are, well, this is what we were going to talk about next, right? Wasn't this my reminder slide?
Yeah.
Ha! I think this is the reminder slide, though. Draw a picture here. So let's say that we have our blockchain.info. All right, and this guy has their own copy of the blockchain. Dun, dun, dun. The blockchain is, of course, shaped like a triangle. It's ironic. Did you text Nick and find out where he is? Very upset. He's turned it into a Caruso. All right, so they're going to have the blockchain. They have their own copy of it. Now, we, as a user, are going to interface with blockchain probably through their API, which we'll talk a little bit about today. That looks like an API type picture, eh? All right, so we have our software. Our software will talk to the API. The API then talks to blockchain.info. Which then fulfills the request from their copy of the blockchain. Okay, so this is the setup. So if we write our software, we are not accessing the blockchain directly. We are trusting this third party, blockchain.info, who's providing for us an API. And we're sending our requests for information from that blockchain through that API. So for example, here is one of my Bitcoin addresses. Sent into their API. So here's all the transactions that have happened with that address. Sent in a JSON format. Okay, so what I'm doing is I'm asking blockchain to show me all the transactions ever associated with this wallet address. Okay, so they are going and searching their blockchain, this guy, getting that result, then feeding that result back to me. But I'm trusting that in the process here, they don't modify that result. They can feed me bad data without ever having to modify the blockchain. Make sense? The trust we're putting into that third party? Now, the good thing for us with this voting system, though, is that it only hurts blockchain.info if they give us bad data. Because the blockchain is the blockchain is the blockchain. We're probably going to validate a vote some number of times. We're going to decide maybe a vote needs to be validated 9 times. We need to have 9 separate sources, all using a public copy of the blockchain, because blockchain is public. If we say it's 9 separate sources, that the vote count should be identical for all 9 sources in order for this vote to be validated. Maybe we decide it's 6, maybe we decide it's 50. Doesn't matter. There's 50 sources of blockchain info out there. So we can decide how crazy we want to get about it. But the point is that if our goal is accurately counting votes, we can accomplish this even if our starting point is through blockchain.info. Okay? We would just have to set up multiple ways of validating the count, and then also rely on third parties to publicly validate, which should then match our numbers. Because if we become the new voting system and we become the replacement for the government, if you will, and we just say, yes, this was the vote count and we validated it 10 times, now we're relying on people to trust us. Rather than you having all the different political parties having their own counters and everybody else having their own counters, and maybe you have 50 or 60 different sources all reporting the same exact vote because they all parsed it off of the blockchain. That makes sense? Their own copy of the blockchain that's out there a bunch of times. So for our purposes in here, for simplicity's sake as well, we're going to go ahead and utilize blockchain.info's API. One thing that lets us do is not have to download a 17 gigabyte file. It also lets us not have to parse through a 17 gigabyte file. Okay? It allows us to ask blockchain.info to do the work for us, and then us just get a nice, manageable document. I mean, this looks worse than it is. I mean, most of this is fluff and white space, right? You think about all the crap that's in here. This is an address. This is a value in Satoshis. This is the index number for the transaction that occurred. So what? There's 120 transactions total to this account. I mean, it just looks like a lot of text, but this is manageable. This is manageable amounts of data for us. This is a couple of kilobytes or something like that of data we're working with here. So we're going to rely on blockchain to give us that data through their API. All right, but we do understand the weakness here of trust. I tend to be the type of person that falls on the side of trust. So I will almost always say this is fine for my own personal threat level. But you have all sorts of, I'm also the same guy that just gives my garage door code out to whoever. So, which is true.
Yeah. And leaves your secret API key.
Yeah, I'm not that trusting. I'm not that trusting.
I do.
Huh?
Your garage door?
Yeah, a lot of people do. Who in here has my garage door code? You can't say it out loud, though. Not because I care, but because it's not classroom appropriate. The funny thing is my pastor also has my garage door code.
Just tell him something else.
No, he is the real one.
Okay.
Yeah, Tabby gives out the politically correct one.
Okay.
I give out the original,
Yeah.
the untainted code. So I texted that to my pastor.
See Hillebrand doing that.
Huh?
Hillebrand looking at his phone. What is that?
He thought it was funny. I sent it to him at Bible study. We were at dinner together for Bible study for an upper room ministry thing. And I said, "Oh, hey, you need my code?" He said, "Yeah, I'll just text it to you so you have it." Whoa. For all of you that are wondering, it is a 4-digit code. I'm not seeing anything else.
4 digits inappropriate. It's like 2 now.
There's like, we're down to 2. Okay, so in any case, I tend to fall into the category of trusting, which probably puts me in the minority of Bitcoin users. I think most Bitcoin users are going to err on the side of I want to manage my own blockchain and my own wallet. What becomes funny about that, though, so let's just talk about that for just a few more minutes. If I'm looking at a desktop wallet, and we're going to go with the hardcore one, the Bitcoin core that's going to download the entire blockchain, you are now responsible for backing up your own keys. So that if something did happen to your computer, you didn't lose all your money. And that there's plenty of stories with Bitcoin where that's happened, where somebody has had a wallet on their computer got trashed or something like that, and they lost thousands of Bitcoins. This is in the early days of Bitcoins when, they were worth a penny or something like that. But imagine that. Imagine you're that person today, and at some point you lost 10,000 Bitcoins. Well, 10,000 Bitcoins times 300 and, what is it, $80 right now or something like that? But whatever. This is ballparky. It's in that zone. 350, 360, 340, 380, whatever. It's $3.8 million that you lost because your hard drive crashed. Something like that. A little bit bigger consequence than if you lose your term paper. So in any case, you're going to have to back that up somewhere. So as computer scientists, where are you going to back that data up? You don't need to back up the blockchain, right? The blockchain is a time thing. So when you reinstall your operating system or get your new hard drive, whatever, you just have to wait let's say, day or two for the entire 17 gigabyte. There's a couple of torrents that you can grab it from as well. But, this guy uses their own source. It takes 2 days or so. You grab the entire 17 gigabyte blockchain and you're done until your next time your hard drive crashes. Because from that point forward, you're just going to be grabbing the new stuff. Small bursts, not 17 gigabytes, more like 17 kilobytes, stuff like that. But where, as computer scientists, where are you going to store your private keys? This is an option for any of you. When you have data on your computer that you don't want to lose, what do you do with it? Where do you put it? What are our options? I had a senior seminar student last year. This is a big project. They work on the entire semester. It's like whether they graduate or not, banks on this. And this person lost their data. Mind you, this was not the first time during this person's 4-year career that they claimed they lost their data. So it was a little fishy to begin with. But in any case, they lost their data. So, oh, didn't you have it backed up? She said, yeah, on my hard drive.
That's not backup.
Yeah, that's not a backup. Okay, so all of us at some point in our lives have lost a file, right? We forgot to save something, power went out. Now the word processors are idiot-proof to some extent. They're backing up in the background for us just in case we didn't hit save. Back in the early days, you had the guy that sat there and wrote a 12-page paper and doesn't hit save till the end and the power goes out. You just want to laugh at them. But, point is all of us at some point have lost some file that we didn't want to lose. It might have ranged from, fairly inconsequential to a pretty big headache, but probably south of $3.8 million in Bitcoin. Probably south of there. But whatever. So we've learned our lesson as we've become, more mature computer users. So what are some ways you back up your data in your computers? Okay, Dropbox. Dropbox is one option, right?
OneDrive.
So let's create a little list. Computer backups. Okay, so we got Dropbox. You said OneDrive, right?
Yeah.
External drive.
iCloud.
iCloud?
Yeah.
The iCloud specifically for your risky photos. I put all of mine up there. I'm not sure why I didn't make the news.
Jennifer Lawrence was that?
Yeah, what's up? So what? She started a couple of movies. All right, what was another one? Email? Okay. So you got a document you don't want to lose. You email it to yourself.
I think just old fashioned, like if we're talking about the private keys, you could actually write those down.
Paper.
Just like hard copy. I think.
Write it on paper. Okay. Yeah, and that's actually a funny for IT majors in here. This is a kind of a funny IT spinoff where any of you in here work for IT? Actually go to people's offices to fix something or something like that. Anybody on campus work for IT? Okay. Well, if you have done IT stuff, have you ever had a situation where you go into, this happens fairly often with faculty members, you walk into somebody's office and right there on their monitor is a little post-it note with their usernames and passwords. They don't want to forget them.
I like the ones that have it like underneath the keyboard, and you think that.
Well, at least that's security through obscurity. I've seen back in the, and I did this years ago, is, they'd have a post-it, and they would label it, Western Illinois University, email account, username, password. It was funny. So, but certainly writing it down on paper is an option. Okay, anything else? Memorize it.
Accessible computers. No.
Okay, well, it maybe falls into the external hard drive thing. Okay, so let's kind of leave it list at this. This kind of covers enough that it lets us have the discussion. So if you back your stuff up on Dropbox, which I use heavily. So here's my Dropbox here. Didn't we look yesterday? So I have 5 terabytes of space. So I could just throw stuff on up my Dropbox forever, and they just keep making this bigger, I think. So I use 13% of that. So whatever that is. But in any case, I use Dropbox heavily. But if I'm going to back up my private keys to Dropbox, who now has access to my private keys? I'm trusting a third party, right? Is that any different than me trusting blockchain.info? Maybe it's one step removed. There's one more layer of security, and that Dropbox maybe doesn't know what these keys are for, especially if I kind of put it in a cryptic folder. Maybe I put it in like Hello Kitty game codes. So I name the folder that. So I just think it's like codes for the Hello Kitty online adventure game.
And then you encrypt it.
I'm waiting for that expansion too. Me at the beach in Florence. All right. So in any case, Dropbox, we are trusting a third party, right? So in the big scheme of things, has somebody who's brought their wallet to their local hard drive really gained anything? Or at least not much, right? One level of abstraction. They're still trusting a third party, but with Dropbox, we're trusting with everything. I have contracts and stuff, business contracts just stored in my Dropbox. My past taxes, all this stuff is just up there, right? So we're trusting a third party. OneDrive, same argument, right? Exact same argument. External drive. Are we trusting a third party for that one? No, we're trusting that 2 drives don't go down at once. Well, if you think 2 drives might go down at once, what can you do? Now you got 3 drives, 4 drives, until you get to the level of comfort where you think you have enough drives that it's going to be impossible for them to all go down at once. And you probably want to have those drives stored in multiple locations, right? Because you have 20 drives, and they're all in your desk drawer or something like that. 20 jump drives. They're all in your desk drawer, and then that's where the fire starts. Although they do have fireproof jump drives now. Have you seen those? Yeah, they have. I think they have jump drives now that will like survive nuclear blasts. They show that they can be run over by a tank and stuff, and they're like fine.
Like EMP proof and all that.
Yeah, like seriously. And then so it's crazy stuff. But so we're gonna have to keep these in multiple locations. For safety's sake. We don't want to rely on the fact that they're fireproof, right? So we're going to keep maybe one of them at the house, another one in our car, another one at work, another one.
And it's nice that you don't need to update. Well, I assume you don't need to update the key at all.
No, keys are issued once. You get a key associated with a wallet. When you first get the wallet, now that's your wallet. Okay, so you have a wallet address, and then you have a public-private key pair that validates you to that address.
Send one off to Africa.
Okay, so how? Email?
Snail mail.
Snail mail?
Yeah.
Okay, so if we're going to put these external drives in a bunch of physical locations, now we're risking the security of those locations. Now, certainly, okay, certainly we're dealing with the issue of at some point you can only be so secure, right? You know, if you put it on 20 hard drives and you scattered those 20 hard drives around the country, chances are somebody's going to come and steal your wallet before you've lost your wallet. Make sense? They're going to steal your coins out of your wallet before you've lost your wallet, because now you have to physically protect all these hard drives. But chances are you're not going to have 20 hard drives die at the same time, especially if they're in different locations, right? Okay. And that's kind of with technology why one of the biggest fears, and there's plenty of documentaries that discuss this type of stuff, but one of the biggest fears for terrorist type of attacks these days deals with EMP blasts and power outages. You know, if we didn't have electricity and all of our computer systems were down, really the world stops, right? Because we're very reliant on that stuff. You know, where historically it was more embargoes on oil and stuff like that, which would certainly be an inconvenience, but we got bicycles, right? Or we can, we'll start running our stuff off of water. You know, we've had that technology for a while, but it's not very profitable for the oil industry, so we don't do it.
Like we have the cure for the common cold, but
oh yeah, I mean,
people don't want.
That's right. Yeah, why cure the cold? Because Robitussin would go out of business. We can't have that. They're one of the pillars of our economy. All right. So in any case, external drives have their own problem. iCloud, same problem as Dropbox and OneDrive. Now, even within these, though, maybe you say, well, okay, iCloud, it's Apple. Maybe I trust Apple a little bit more than random dude X who says he has cloud storage. Possibly, right? You know, I think we maybe use this example one other time in here about purchasing stuff. None of us would have, well, generally speaking, if you were to order something off Amazon, you wouldn't have a problem sending Amazon cash in the mail. You'd trust that Amazon would send you your product because they're Amazon. They've built a trust for us. But, when Amazon first started, or let's say Steve here decides he's going to create his own shopping site, it just came out, yeah, crimes are, he sells various products like bleach and United States dollar currency paper, that type of stuff. And you probably are going to be very hesitant to send him cash for the products, right? You'd probably be very hesitant to send him anything for his products, but certainly not cash because you don't trust the source. So even within cloud computing, you might say, okay, well, Dropbox has been around for a while. Kind of one of the, proverbial pillars of cloud computing. So maybe we say Dropbox, pretty trustworthy. They're enough in the public eye that it would hurt them if they started, doing bad things regarding their customers. Same thing with iCloud with Apple. Now, that doesn't mean that these technologies can't have their problem. iCloud, famously in the news this year, right? Was that that didn't make us trust Apple less. It probably just made us trust cloud computing less. That, hey, none of this stuff is foolproof. If anybody can do it right, maybe it's Apple. But, man, something went wrong, right? I think Dropbox had a similar problem not that long ago where a bunch of passwords were lost or something like that. Or exposed. I don't know exactly. Maybe it was even credit card numbers for people with paid Dropbox accounts. But in any case, Dropbox has the same problem. OneDrive. That's not Microsoft, is it?
Yeah.
That's Microsoft's thing. What did it used to be called?
SkyDrive.
SkyDrive. That's right. All right. So again, we're going to trust Microsoft, right? But none of these guys are above failure. But chances are Dropbox, Microsoft, Apple are not going to go into your cloud site, specifically steal your private keys and use them or sell them to somebody. We probably can trust that. That doesn't mean somebody else isn't going to breach their security and gain access to your account. Okay? External drives have their own problem. What about email? Is email really any different than cloud computing stuff? Yeah, so if you send your if you send the address, your private keys through your Gmail account, so it's stored on Gmail, which we do. I mean, most of us probably still do that today. We send something. I keep most of my serial numbers and stuff like that on Gmail, so I can just do a quick search. I have my Windows 7 key, my Windows 8 key, and if I need to access those things, I don't have it written down somewhere. I'm just going to jump on there and find it real quick. So, email really has the same problem. We're trusting Google to not steal stuff from our, email account, not mine our email account. We already know that to some extent email or Google does mine our email, but we're hoping that they're doing it ethically. Because when you go into your Gmail, they're giving you advertisements, right? And the advertisements are related in some part to the contents of your email. But the idea is that that stuff's never shared. It never actually hits human eyes or anything, but whatever. Bottom line is we probably trust Google. We know they're stealing our crap, but we figure they're not going to use it for bad stuff. They're probably not going to sell lists of stuff like that to other people. They're using it to make their own stuff better. But email is going to have the same problems. What about paper? Similar problems to the external hard drive, but just scarier. I suppose you could write your private keys down on paper and then store it in a, safety deposit box at a bank. Now you're trusting the bank, or you can store it in your own, flame retardant box inside of a giant safe, bury it underground. Build a house on top of it. Your computer crashes. You have like a major excavation type dig to go. It's going to be 2.5 weeks before I get to that safe. You find out it's all rusted out. So,
only have like the first two numbers of your key.
Yeah, that's right. Yeah, you find out the paper was really the eco-friendly, biodegradable stuff. Basically, it was you wrote this thing on boat toilet paper. So, what about memorizing it? Yeah, we're relying on our memory, right? Okay, so and I can tell you firsthand, I have a very, very good memory, and I like to think that my memory is better than most people even today, but I can tell you that my memory is not as good today as it was 5 years ago. It's just, you start going downhill, and sometimes I have to think about my social security number and stuff like that to come up with the digits. But in any case, memory has its own weaknesses. You don't want to forget a digit and not be able to access your wallet. So in any case, backing up your wallet, if you're going to do this if you're going to have a physical wallet, even requires you to trust somebody, right? The only real version of this for you trusting yourself is, memorizing is probably the ultimate of trusting yourself, because you are really trusting yourself at that point, okay? Paper or external hard drive / jump drive / something like that. That's it. And external hard drive, you're only trusting yourself as much as you keep those things in possession that only you can, at a place where only you control. And then you have problems with security of those places. Okay? So, punchline there is, my argument is I'm not sure why things like this make tons of sense. I suppose you can make the argument today that I'd rather deal with the security on my own right now because I don't yet trust these sources. It's possible. I've been using blockchain info and Coinbase for a while, but that doesn't mean they're trustworthy. We certainly aren't going to put these guys in the same category as Amazon or eBay or Google or Apple. They haven't earned that yet, right? So, especially when you consider the news surrounding Bitcoin stuff, even just this week, they're calling it Silk Road 2. It's a sequel to the original Silk Road. It was the whole underlying the black market related to Bitcoin stuff. Yeah, they just crashed it again. So the government, they went in there and they caught him the first time. And then unbeknownst to them, it started again, and now they caught him again. Okay, and then you had Mt. Gox, which was at the time the most trusted Bitcoin exchange. By far, Mt. Gox was the place. and they failed horribly, right? So, you can make the argument for that. We don't know yet who to trust here. There hasn't been enough established data to trust anybody fully yet. If Apple or Google starts diving in here to cryptocurrency type stuff and they start hosting wallets, maybe we trust that a little bit more. Maybe. We maybe put it on a similar thing to like our iTunes account. How many of you have an iTunes account and have a credit card store with Apple? Probably several of us, right? Huh?
The one that I had expired. So.
Okay.
So
Well,
no.
they have a credit
Not
card.
anymore.
Well, you're not Amish. You're not supposed to use credit cards anyways. Actually, having a credit card is probably not technology. Using the credit card would be using technology. Although plastic. Do Amish people use plastic? It's hit and miss. But in any case.
Maybe the swiping, like using the machine, would be illegal, but they could like have the cashier do it or like tell them the numbers.
Maybe the card just like lays on the Apple Pay thing by accident.
Well, I actually did experience yesterday, after I used Apple Pay at the Apple Store, my wife wanted to go over to that Bath and Body Works, where she sprays a bunch of pieces of paper and then hands them to me to hold them for them to dry so she can smell them later. That's my job, that store. But in any case, so we went to check out with this bag full of spray jars, all of them for me, of course. I asked them, "Do you have Apple Pay?" And so I was, I didn't expect them to have Apple Pay, but the lady looked at me and she's like, "I don't know." So it's kind of an interesting challenge related to alternative payment methods. Is how do they end up taking over, because we're so set in our current ways of making payments. You kind of got to roll back. I remember not well. I was young, but in the early days of credit cards, because when I was a kid, we didn't have credit cards. They or at least they were not commonplace. So everywhere you went, you paid cash. Well, now we rarely pay cash for stuff. Credit cards or debit cards, that's the convenience. And when you go into a store and you hand the person a credit card, they know what you're doing. In the early days, I wonder how often it happened where they looked at it and said, what am I supposed to do with this? Because any of you ever been to a place that had to do, they do the carbon copy of your credit card? You ever had that? Yeah, that's what they used before they could, before they had machines to swipe. So you go in there, if you were paying by credit card, they'd write you up a receipt, and you'd sign the receipt, and then they would, the receipt thing was on like this carbon paper, and they put your card on it and put it through this machine where it was a manual machine where they just pulled this like weight across of it, and what it would do is it would imprint your card on the carbon paper, so they'd have a copy of your number. And then they hand you the receipt, and then I'm guessing at the end of the week they would send those into the credit card company or whatever to be processed. So I still see them sometimes if you go to any like street vendors or something like that. I think like the last time I saw one, went to some Indian reservation place where they were selling like jewelry and stuff like that. They took credit cards and that type of stuff. But in any case, that could be a challenge of alternative payment methods that we have to kind of move past that transitionary period. Okay, so wallet addresses are going to be problematic. Let me just kind of wrap up here real quick. So wallet addresses are going to be problematic. So we're going to say it's okay. We're going to say it's okay for us to trust blockchain for our example. Okay, especially because they provide an API. So what we're going to look at next time is we're going to look at a simple JSON engine, since we didn't finish ours. So this is something you can get it from code.google.com. It's a project called JSON Simple. We'll look at a little example of that. Then we're going to look at the API here for blockchain.info. And ultimately, we're going to move towards parsing something like this, which would be an example of grabbing all transactions associated with a particular wallet address on the blockchain for counting votes. That make sense? All right. Have a good weekend. I will see everybody on Monday.